So for many decades, scientists have known that as we get older, we lose our capacity to repair DNA, and this leads to cancer and overall aging and deterioration. In this new study, we've discovered what we think is a main mechanism that controls this process, and even, we think, some ways to reverse it. What we've discovered specifically is that when we're young, there's a protein that repairs our DNA efficiently. But as we get older, there's another protein that sticks to it, and that stops it from working. In one experiment, we fed old mice, the equivalent of about an 80-year-old human, a molecule called NMN, which then the mice turned into another molecule called NAD. Now, NAD is essential for life, and what we found out is that when you add it to the mouse's diet, it pops these two proteins apart, and this protein can now be as active as it was in a young mouse and restore our youthful levels of DNA repair. Effectively, this restored the DNA capacity of the old mice back to that of a young mouse, and also removed the DNA damage that was accumulating in their tissues. In another experiment, we exposed the mice to radiation, and our treatment greatly improved their DNA repair capacity and lessened the effects of the radiation exposure. We're particularly excited about doing a human trial over the next few months and seeing if these results translate to people. As we age, the tiniest blood vessels in our bodies wither and die, reducing the blood flow to organs and tissues. Vascular aging causes many diseases: cardiovascular, neurological, muscle wasting, frailty, and even aging. Here at Harvard Medical School, we've reversed this process in mice, setting the stage for radical new therapies to help people. The new study has unraveled the cascade of interactions between blood vessels and muscles. Endothelial cells, which line the walls of blood vessels, are essential for the health and growth of the vessels. And as endothelial cells age, blood vessels begin to atrophy and die. Blood flow to many parts of the body diminishes. Organs and tissues begin to function less well. Blood vessel demise hits muscles especially hard, because muscles rely on a robust supply of blood for their function. This process can be slowed down with regular exercise, but only up to a point. Over time, even exercise fails to stave off blood vessel demise and muscle loss. The new findings have cracked the mystery behind this process. As our blood vessels age, they become deaf to the signals from exercise muscle. This actually leads to the muscle shrinking as we get older, and therefore we're less able to exercise and grow new blood vessels. A vicious cycle indeed. The two key players in the crosstalk between blood vessels and muscles are a molecule called NAD and a protein called SIRT1. NAD boosts SIRT1, which in turn enables the conversation between muscles and blood vessels. But both NAD and SIRT1 decline as we age. They can no longer perform their role as the interface between the muscles and blood vessels. In our new study, we gave mice NMN, a chemical compound commonly found in the body and previously shown to boost NAD levels, which in turn boosts SIRT1. These mice had better endothelial function, blood vessel growth, and improved blood supply to their muscles. And what was most striking? These animals' capacity for exercise improved dramatically. In fact, the old mice treated with NMN had up to 80% greater exercise capacity compared with the untreated old mice. These results, I believe, can help millions of people who have lost their mobility or simply can no longer exercise, either through frailty, disability, or old age. This sets the stage for new medicines that will be able to restore blood flow in organs that have lost it, either through a heart attack, a stroke, or even in patients with dementia.